Welcome back, YouTubers, to my channel. I'm doing a little Sunday project. I've been meaning to build a signal tracer for some time. The idea of the signal tracer is if you're doing amp repair, you can inject into the amp a signal from your signal generator. Any source really, it could be a record player, cell phone, whatever you've got to put some sort of audio signal into your amp. And then you can trace it with the tracer. So the idea for this project I found on the internet. There's a chap out there called David Taylor, an English guy, who in August of 2017 put this diagram out on the net, and he's also shown how he built his with a tag board layout, which you can see here. And then he put it in a box, which I'll show you. There we go, it's quite a large box. So my feeling was, for this type of project, I don't know that a tag board is really necessary. I think this is going overboard. There's so few components. I think point-to-point wiring would be fine. So my first challenge was to find an enclosure, and on eBay there's a UK company that makes small plastic box enclosures. They're ABS boxes, and he gives the external dimensions and the internal dimensions, and I wanted to make it as small as possible. I didn't want anything too bulky, and I wanted to make it so that I could disconnect the jack plug that feeds the amp and the probe at the other end. So once the two things are disconnected, you've got a relatively small box, which is easy to store. I don't want anything with wires hanging off it because they're always getting tangled up everywhere. So I decided on the 60 by 40, that's the interior measurement of the box, and I started laying out my components inside the box. I put the jack here, connector there, the switch for the radio frequency, audio frequency is just a basic switch, I've got it here. And then there are the four components, the two capacitors, the diode and the resistor. It's only four electronic components. So this is the box, and you can see I've put tape over it. This is just painter's tape, and what this enabled me to do is to mark out where the center was and figure out exactly where I want in this case it's the BNC connector to go. On the other side I did the same thing. I marked it out, measured it, did a little cross in the center, and that's to take the drill bit for the jack socket. And on the side here is a little bit more difficult. I drilled through with two 6mm drills, sort of side by side, just went through, made two holes, and then with a angled file, like a triangle file, I just squared the ends off and then moved backwards and forwards on either side. At which point I was able to drop the switch in and line up the holes and mark the two holes on the tape, and then I drilled through the same size as these holes here so that I can push the screws through, or actually they're bolts. I'm going to push two little bolts through and bolt them up on the inside. And at that point then this is ready to have the tape removed. I'll just peel that off. Now I might add that while I was drilling this I made two blocks of wood. One that was just this high and one that was this high, and I pushed the wood in and it was a fairly snug fit, and then I put this in a vise, and I was able to use my drill press so that it didn't move around, and I was able to get a fairly clean hole on both ends. But that stopped the ABS from deforming in any way and enabled me to get a decent solid surface to drill into. I think that worked well. I think it's worth doing because this is fairly flexible, and if it starts deflecting when you're drilling, the drill may wander and you won't get everything lined up the way you'd want it. These are Marshall type jack sockets, and these are connected together when there's no jack plug in it, but when you push the jack plug in, these two terminals lift and these two make contact with the cable, not these at the bottom. So when you put it in and you wire it up, if you're using this type of socket, just be aware that you've got to look at the top, and it's the two connectors there, follow them round, and then use these two to do your soldering. I'm just putting this together to see if it's going to fit. So I want to put the terminals again uppermost so that I can sort that out. So that fits. It's pretty tight, but there is clearance there between the terminals. And then the BNC connector, that comes in from the outside. It's a little bit different. It's just loosely laid out there, but you can see that's pretty much the way it would go. It's a little bit tight here, definitely, so I thought I might just swap that out for the Fender American style jack and see what difference that makes. So there it is with the American style jack plug-in. That's the type you get in guitars and so on. So you've got an option there. The Marshall will work just as well. So I'm going to draw your attention to the layout design. In the end it did differ slightly from what I ended up building here. As you can see in the design, the switch is on the bottom. It's got the jack to the jack socket to the right, the BNC to the left, and the switches at the bottom. I've actually ended up putting it at the top. It does give me a little bit more room in this corner here to sort of run some wires, so I felt that might be the better way to do it. Now, looking at the switch, when it's to the right, nothing is switching through because there's nothing connected to this terminal. So on the 3 terminals on the switch, you'll only be wiring to 2. So when it's over to the right, this capacitor is connecting and going through to the amp, and this one is coming through here. It jumpers with the wire which goes over here, and it connects to the 2M2 which goes over here. Nothing is connecting to the germanium diode. This is left sort of floating, it doesn't go anywhere. And when you switch it over to the left, this is now in circuit. So you have this coming through to here. You also have it connecting to this through the switch, so it kind of goes here, it's connecting here as well, and it's carrying on through here. So this is then in circuit. So this is how this switches in and out. So when you wire it, you just have to be sure that you only use 2 terminals. And you have the 2M2, I put it in the center, and the IN34 on the outside. Now whether that switch is up there or down here doesn't matter, as long as you have 1 terminal free and you use the 2M2 to the center terminal, you should be fine. So looking at it once more, the 0.47 UF comes to the center terminal and continues on with the wire, and also the 2M2 connects to the center terminal but goes to the positive terminal, or the live end, if you will, of the jack plug. So you've got the ground end and the live end here. So on the live end you have 3 components coming together. You've got this 0.01 UF capacitor, it's going to there. You have the germanium diode, and you have the 2M2. So 3 of the 4 components are connecting to the live end or the positive end, and 1 component is connecting over here to the ground, but it is on its way connecting to the 2M2 here and then sort of bouncing off again. So that's pretty much the way that works. So I drew this out, and this is basically the same thing as the circuit diagram, but it gives me a spatial reference or a wiring reference that I can use when I start putting it in here. So in effect I'll be duplicating that in this box, but I will be putting the switch at the top. So I'm starting to assemble the box. I'm still waiting for some screws to arrive to put the switch in, but in the meantime I'm going to start putting some of the components in. So the first thing I'm doing is I'm connecting from the live terminal, which is the inner one, excuse me. This one here is this one here. I'm connecting the 0.01 UF capacitor to the probe. So it's running from here. I've kind of done it at the right angles here, and I'm pushing it into this the live portion of the probe here. And then the next thing I'm going to do is to tin these wires. I'm going to be running a wire from this end, and that will run to the center of the switch when it's installed, and that is basically this wire here running to the switch center, at which point there'll be another 0.047 UF capacitor which will connect to the same point, and then that will run over here to the ground terminal of the BNC socket. So the last thing is to attach the germanium diode to the switch. That's going to be a little bit tricky. There's a close-up of everything. So I'm making the last connection to the BNC connector, 0.01 UF capacitor. I put some flux on this. There we go. Okay, so this is what I ended up building. I just redrew it. It's a little bit different, the layout's slightly different. I put the switch up here instead of down here from the previous diagram I showed you. The reason for that was that I felt by doing that I had more room here to wire in the componentry, which is true, it worked better that way. I didn't see that though until I built the box, drilled the holes, and I realised it would be better to do it this way. So basically this is the probe side, which goes to the circuit under test, your amplifier that you're testing or your radio. Over here is the audio side, that's basically to the amplifier that I'd be using the small guitar amp to check the sound, to listen to the amp, make sure that I'm getting volume at the various stages. This switch is a two-way switch. In this position you're probing for radio frequency, RF, and when you move it over to this side it disconnects the IN34, the germanium diode, this little thing here, takes it out of circuit, and you're probing for audio frequency just by switching that over to that side. So this box of nuts and bolts arrived. There's 440 nuts and bolts in there, different sizes, basically 3, 4 and 5 mil in different lengths with the appropriate amount of nuts. All stainless steel, but I was able to get from that these little ones here, which will be good for the switch. And I have this selection of washers. These are lock washers. I think this one might be the right size. Have a quick look. Yeah, that looks about the right size. The whole problem here is to try to screw this, so I might be able to do it this way, holding the nut. Okay, at this point, see if I can grab the nuts with the pliers. Just tighten it up a bit. That's good. Try the same thing with this side. Okay. Here it is now, all finished. Nice blue box, got your switch, nice screws on the bottom, nice and shiny. There's your jack socket to go to the amp, BNC, very small, quite lightweight, very compact, very useful. Total cost, I think it was less than £10. I had to buy 2 of these and a few jacks and obviously a large box of screws, but the most expensive thing was the ABS box, which was £6.50. They come in all different colours. They've got orange, red, yellow, green, grey, black and white. So anyway, I hope that was useful. If you want to build one, you can follow this video and I'm sure you'll get there. I thought I should show you this signal tracer in action just to make sure that it works. So what I've done is I've taken an oscilloscope probe and I've attached it to the end that was designed for it. That gives me the opportunity to hook this onto various parts of the amplifier, so I don't have to get in there too close. The other end of the device is just connected into this mini Fender. It's a battery operated amplifier. Up here I have a signal generator that's outputting a signal which has a BNC connector, then it has an adapter, and then it has a jack plug that's going into the front of the amp. So in effect here I'm sending a signal into the front of the amp. I'm going to capture the signal at various points in the amplifier with the oscilloscope probe here, and we should hear it coming through the amplifier, which proves that this is working. Before I demonstrate the signal tracer, I just want to show you something. This is the 12AX7 inside the amplifier here, and on pin 1, if you look at the meter, the orange meter, you can see here 247.4 volts on pin 1. Okay, so the signal's coming in here into the amplifier from the signal generator, and I'm going to take the probe and I'm going to touch it to this terminal here, which comes directly off the jack, and we should hear the signal from the generator. Okay, so that proves that it's allowing the signal, the AC, to pass through. Now that comes down to here, which is the second terminal on the valve or the tube. Let's listen to that. You can hear it there. There's also high DC voltage on this tube, and without this box that I built, that would have blown the amp up. Basically it would have gone into the amp and damaged it. So what we're going to do now is listen to it here. It shows that the device is working, and even when it comes in contact with high voltage, it's not doing any damage to the amplifier. So that's the first stage of amplification. That's the second one, which is much louder. So you can turn the volume down on the amp, but basically it works. If you want to have one of these audio tracers, you could build the one that I built, and you know that it works. If you do go ahead and decide to build one, please make a small donation. We'd most appreciate it. Other than that, please subscribe and leave a comment. I'll try to answer your questions if I can.